Welcome to the post-class video on acids and bases.
Okay.
So the first part of the activity, we kind of reviewed a little bit of things about acids and bases that we knew. But maybe one thing that we are asking you to do now is to be able to predict the outcome of reactions.
Right.
So here I have written up an acid and a base, and they're going to react. And we know that what happens in an acid-base reaction is that a proton, or H+, gets transferred. So the first thing we have to be able to do is identify which is the acid and which is the base. Well, they both have hydrogen, right? So they could both potentially be acids.
Mm-hmm.
What are the clues that one's an acid and one's a base?
There on the left, that compound has a hydrogen in the front. It's not usually in the front.
Yeah, usually, so the hydrogen here is in the front, there it's in the back. Acidic protons usually are written at the beginning. The exception to that is things like acetic acid, where we write CH3COOH. But if there's a hydrogen at the front, it's usually an acid.
Mm-hmm.
The other way is by looking at this, and this OH together, that looks like hydroxide, which is kind of the primal base.
Right.
Okay, so what's going to happen in this reaction?
Well, that proton is going to get donated to the base and form your conjugate base from what used to be the acid, and your conjugate acid from what used to be the base.
Yeah, and the H and the OH get together to form water, a covalent compound.
Oh yeah, can't forget about that.
And we're left with B bromate ion and rubidium ion. So we're left with bromate ion and rubidium ion. And this is the conjugate base of the acid.
Right.
This is the conjugate acid of the base. It might look weird, I mean that's just a metal ion, but it turns out metal ions can act as acids.
Right, and these are in equilibrium, right?
Yeah, and so probably I ought to drill a little arrow there.
Right.
Although this is an example of a reaction that for the most part gets driven all the way over.
There you go.
Right. The other thing I want to point out is that I'm being a little bit sloppy here in that I'm not indicating AQ for all of these. Right? So even chemistry professors that have been doing this for a long time, sometimes we get hasty and forget to do the proper thing. And that can actually get me in trouble if I try to write out an equilibrium expression for this and I forget that the liquid doesn't participate in the equilibrium expression. Right? It's in the reaction, but not in the equilibrium expression. So the second part of the activity was all about H+ and quantifying H+, and we developed the idea of converting a hydrogen ion concentration to pH, and how do we do that?
Negative log.
Negative log of H+
Will give us the pH.
gives us pH, and if I want to convert a pH to H+,
you would do the opposite of that, which is raise it 10 to the...
10 to the negative pH equals the H+ concentration, right? So we can get back and forth between these two.
Mm-hmm.
We also learned that H+ concentration and OH- concentration are also tied together. And that's tied together by that fantastic thing called Kw.
Right, the equilibrium.
Yep. The auto-ionization of water. And this has a value of 10 to the minus 14. Approximately. It actually varies a little bit with temperature, but that's a number that you should actually memorize because you're going to use it enough. 10 to the minus 14. Right, so if I know H+, I can use this Kw to calculate OH-, because guess what? This times that equals 10 to the minus 14.
Right.
Okay. Well, we can also define POH. Right? What's POH? 10 to the negative log, or negative log of OH.
It's just like it's just like pH except OH instead.
Yeah,
so
exactly.
not that difficult.
Exactly. And then therefore, since these two are tied together, these two are also tied together. And this one's a little bit easier, and that pH plus POH equals 14.
Right.
So the key is that if I know one of these things, any of these four things, I can calculate the other ones.
All three of the other ones.
Yep. So if I have pH, I can directly calculate H+, or I can directly calculate POH. If I want to know OH concentration, I have to go around the loop, right? So you have to do two steps.
No shortcuts here.
No shortcuts. You can't go diagonal across. But that's a really powerful thing.
Right.
Okay? And so I think that covers pretty much what we did in class today.
All right.
So just basically reminders, I think, today. All right. See you in class.